Before we proceed in our discussion, let me present to you our objectives. At the end of this video, you should be able to recall the difference between permutation and combination, determine if a given problem is about permutation or combination, solve problems involving permutation of objects, solve problems involving combination of objects. Let's get started. In our previous lesson, we already determined the difference between permutation and combination. We learned that permutation is all about arrangement and combination is about selection. Visualizing the problem is the first step in solving problems about permutation and combination. In this video, we will solve 7 different problems involving permutation and combination. You may answer each question by pausing the video before it reveals the correct answer. Let's start. Problem number 1. A shelf can hold only 6 books. Given that 10 books are available, find the number of different arrangements that can be made to fill the shelf. The keyword used in this problem is arrangements, which means order matters. Thus, this is a permutation question. Since this is a permutation question, we can solve it using permutation of 10, 6. Since 10 books are available, so n is equal to 10, and we will arrange 6 books in a shelf, so r is equal to 6. Again, n is equal to 10 and r is equal to 6. Let us use the formula for permutation of objects, which is permutation of n, r is equal to n factorial over quantity n minus r quantity factorial. By substituting the value of n, which is 10, and r, which is 6, we have permutation of 10, 6 is equal to 10 factorial over 10 minus 6 quantity factorial. Evaluate the equation. 10 minus 6 is equal to 4, so the resulting equation is 10 factorial over 4 factorial. We can write the numerator in the form of 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial, so that we can cancel 4 factorial on both numerator and denominator. Multiply the remaining factors. 10 times 9 times 8 times 7 times 6 times 5 is 151,200. Thus, we have 151,200 different arrangements that can be made to fill the shelf. Problem number 2. Picking 2 secretaries and a treasurer from a group of 10. How many possibilities are there? The keyword used in this problem is picking, which means order is not important. Thus, this is a combination question. This problem can be solved using combination of 10, 2 times combination of 8, 1. Since we have 10 members and we're going to choose 2 secretaries. Then after selecting 2 secretaries, out of 10 members, only 8 members are qualified to be a treasurer, and we will select 1. In short, we will multiply the number of combinations of secretary to the number of combinations of treasurer after selecting 2 secretaries. Applying the formula for combinations, which is combination of n, r is equal to n factorial over quantity n minus r quantity factorial times r factorial. Let us first solve combination of 10, 2. So n is equal to 10 and r is equal to 2. By substituting the given values, we have combination of 10, 2 is equal to 10 factorial over 10 minus 2 quantity factorial times 2 factorial. Evaluate. 10 minus 2 is equal to 8, so we have 10 factorial over 8 factorial times 2 factorial. 10 factorial can be written in the form of 10 times 9 times 8 factorial, so that we can cancel 8 factorial on the numerator and denominator. Simplify, we have 10 times 9, that is equal to 90, and 2 factorial is 2 times 1, which is equal to 2. Last step, 90 divided by 2 is equal to 45. Hence, combination of 10, 2 is equal to 45. Now, let us solve combination of 8, 1. Again, apply the combinations formula and substitute the given values. This time, our n is equal to 8 and our r is equal to 1. So we have combination of 8, 1 is equal to 8 factorial over quantity 8 minus 1 quantity factorial times 1 factorial. Evaluate, 8 minus 1 is equal to 7, so we have 8 factorial over 7 factorial times 1 factorial. 8 factorial can be written in the form of 8 times 7 factorial, so that we can cancel 7 factorial on the numerator and denominator. So we have 8 over 1. So 8 divided by 1 is equal to 8. So combination of 8, 1 is 8. Therefore, we can multiply 45 times 8, which is equal to 360 possibilities. Problem number 3. How many 5-digit telephone numbers can be formed if each number starts with 81 and no digit appears more than once? We all know that the arrangement or the position of the digits in a telephone number is important. Thus, this is a permutation question. Let us analyze the given question. We are going to form 5-digit telephone numbers, but the first 2 digits are already placed, which is 8 and 1. So only 3 digits are remaining. According to the problem, no digit appears more than once. So we cannot use 1 and 8 because they are already placed on the first and second position. Number 2, 3, 4, 5, 6, 7, 9, and 0 are the only digits available for the 3 remaining digits in a telephone number. Thus, we can solve this using permutation of 8, 3, since we have 8 digits available for 3 remaining digits in a telephone number. Since the problem can be solved using permutation of 8, 3, hence our n is equal to 8 and r is equal to 3. Let us use the formula for permutations of objects, which is permutation of n, r is equal to n factorial over quantity n minus r quantity factorial. By substituting the given values of n and r, we have permutation of 8, 3 is equal to 8 factorial over quantity 8 minus 3 quantity factorial. Evaluate, 8 minus 3 is equal to 5, so we have 8 factorial over 5 factorial. 8 factorial can be written in the form of 8 times 7 times 6 times 5 factorial, so that we can cancel 5 factorial on the numerator and denominator. Multiply the remaining factors. 8 times 7 times 6 is equal to 336. Thus, we have 336 telephone numbers can be formed. Problem number 4. 5 different letters are to be chosen from the first 10 letters of the English alphabet. How many choices contain 2 vowels and 3 consonants? The keyword used in this problem is chosen, which means order is not important. Thus, this is a combination question. By analyzing the problem, we have 10 numbers of objects. The first 10 letters of the English alphabets are A, B, C, D, E, F, G, H, I, J, which compose of 3 vowels A, E, and I. More so, the remaining 7 letters are consonants. According to the problem, we're going to choose 5 different letters containing 2 vowels and 3 consonants. Hence, this problem can be solved using combination of 3, 2 times combination of 7, 3, since we have 3 vowels and we're going to choose 2. Also, we have 7 consonants and we're going to choose 3. Applying the formula for combinations, which is combination of n comma r is equal to n factorial over quantity n minus r quantity factorial times r factorial. Let us first solve combination of 3, 2. So n is equal to 3 and r is equal to 2. By substituting the given values of n and r, we have combination of 3, 2 is equal to 3 factorial over quantity 3 minus 2 quantity factorial times 2 factorial. Evaluate 3 minus 2, which is equal to 1, so we have 3 factorial over 1 factorial times 2 factorial. 3 factorial can be written in the form of 3 times 2 factorial, so that we can cancel 2 factorial on the numerator and denominator. So we have 3 over 1. 3 divided by 1 is equal to 3. Thus, combination of 3, 2 is equal to 3. Now, let us solve combination of 7, 3. Again, apply the combinations formula and substitute the given values. This time, our n is equal to 7 and r is equal to 3. So we have combination of 7, 3 is equal to 7 factorial over quantity 7 minus 3 quantity factorial times 3 factorial. Evaluate 7 minus 3 is equal to 4, so we have 7 factorial over 4 factorial times 3 factorial. 7 factorial can be written in the form of 7 times 6 times 5 times 4 factorial, so that we can cancel 4 factorial on the numerator and denominator. Multiply the remaining factors. 7 times 6 times 5 is equal to 210 over 3 factorial is 3 times 2 times 1, which is equal to 6. Last step, 210 divided by 6 is equal to 35. Thus, combination of 7, 3 is equal to 35. Multiply 3 times 35, we have 105 choices contains 2 vowels and 3 consonants. Problem number 5. How many ways can you arrange 2 blue marbles, 4 red marbles, and 5 green marbles? Marbles of the same color look identical. According to the problem, the keyword used is arrange, meaning this is a permutation question. Also, according to the problem, some of the objects are identical. That's why the type of permutation that we're going to use is distinguishable permutation. Let us use the formula for distinguishable permutation. P is equal to n factorial over p factorial times q factorial times r factorial, where n is the total number of objects, p, q, and r are the total number of each identical objects. So n is equal to 11 since 2 plus 4 plus 5 is 11. Let's say P is equal to 2 for blue marbles, Q is equal to 4 for red marbles, and R is equal to 5 for green marbles. Let us substitute the given values to the formula. We have P is equal to 11 factorial over 2 factorial times 4 factorial times 5 factorial. We can simplify the numerator 11 factorial. You can solve it by using your calculator, which is 39,916,800. Simplify first each factors. For 2 factorial, we have 2. For 4 factorial, we have 24. And for 5 factorial, we have 120. Now, multiply the factors in the denominator. 2 times 24 times 120 is equal to 5,760. Last step, 39,916,800 divided by 5,760 is equal to 6,930 arrangements. Problem number 6. How many triangles are determined by 8 points, no 3 points of which are collinear? This is an example of 8 points wherein no 3 points are collinear. In the problem, we don't have any keyword, but we can answer it by visualizing the problem. The problem is all about triangles. These are the example of triangles formed using the given 8 points. Let's say we have triangle. We can name this triangle as triangle ABC or triangle BCA. The order of the letters is not important. Thus, this is an example of a combination question. In the given problem, we have 8 points, so n is equal to 8. More so, we are asked to determine the number of triangles formed. Since 3 endpoints are needed to construct a triangle, therefore we have r is equal to 3. Thus, we can solve it using combination of 8, 3. Applying the formula for combinations, combination of n, r is equal to n factorial over quantity n minus r, quantity factorial times r factorial. Substitute the values of n, which is equal to 8, and r, which is equal to 3. So we have combination of 8, 3 is equal to 8 factorial over quantity 8 minus 3 quantity factorial times r factorial. Evaluate 8 minus 3 is equal to 5, so we have 8 factorial over 5 factorial times 3 factorial. 8 factorial can be written in the form of 8 times 7 times 6 times 5 factorial, so that we can cancel 5 factorial on numerator and denominator. Multiply the remaining factors. 8 times 7 times 6 is equal to 336, and 3 factorial is 3 times 2 times 1, which is equal to 6. Last step, 336 divided by 6 is equal to 56. Therefore, we have 56 triangles formed. Problem number 7. 2 different math books, 4 different chemistry books, and 3 different physics books are arranged in a shelf. How many arrangements are possible if the chemistry books are arranged together at the end of the other books? The keyword used in this problem is arrangements, which means order matters. Thus, this is a permutation question. To solve this, we must visualize the problem first. According to the problem, the chemistry books are arranged together at the end of the other books. So we will group them as set A. And set B are those non-chemistry books, which are math and physics. Hence, this problem can be solved using permutation of 4, 4, since we have 4 chemistry books and we are going to arrange them together, times permutation of 5, 5, since we have 5 non-chemistry books and we're going to arrange them together, times permutation of 2, 2, since we can arrange the 2 sets of books in a shelf, both chemistry books and the non-chemistry books. To solve this, let us use the formula for permutations of objects taken all together, since both n and r have the same values, and that is permutation of n, n is equal to n factorial. First, let us solve permutation of 4, 4, which is equal to 4 factorial. 4 factorial is 4 times 3 times 2 times 1, that is equal to 24. Next, permutation of 5, 5 is equal to 5 factorial that is 5 times 4 times 3 times 2 times 1, which is equal to 120. Last, we have permutation of 2, 2, which is 2 factorial, that is 2 times 1, which is equal to 2. Last step, multiply the results. 24 times 120 times 2 is equal to 5,760 arrangements.